Hi, this is Logan Spawn. I recorded my submission for the Heat and Mass Transfer Challenge Assessment number 2. I want to start off by talking a little bit about energy insecurity. So a household is energy insecure when it is unable to meet its energy needs, and this happens when the homeowners either can't pay for energy or just don't have access to it. This problem is becoming increasingly significant as energy bills increase along with the average household energy usage. A study conducted by the Children's Sentinel Nutrition Assessment Program found that energy insecurity was associated with increased odds of hospitalization, poor self-reported health, developmental concerns, increased odds of food insecurity. That's all after adjusting for household characteristics. Some further consequences could be poverty, job stresses, poor housing quality, asthma, just mental stress in general, parental stigma, or family disruption. A way to combat energy insecurity would be to improve window insulation. So because building energy makes up nearly 60% of all energy consumption, that would be the area to target if you want to reduce your energy consumption. So windows themselves have a very low R value, and they allow a lot of heat to pass through. And according to an office of the U.S. Department of Energy, about 30% of a home's energy is lost through its windows. So replacing or upgrading a window can be a low-cost home improvement that helps families to be more energy efficient, and save money on energy bills. So a family would have a couple options when it comes to replacing their windows. They could use a single pane. They are made with a single layer of glass. It costs a little bit less up front, but they don't have the insulation, therefore are not as effective at keeping out noise or limiting heat transfer. And an R value of 0.9. The double panes, they have an R value of nearly double that. They're made of 2 panes of glass separated by air or other insulation. They cost a little bit more up front, but they can limit noise and are way more effective at insulating heat. So here's a problem that I did in class, kind of simulating a double pane window. They got 2 steel plates connected with steel bars with fiberglass insulation in the middle. First step towards solving this problem was listing out all the givens using firstly a hand calculation, drawing a diagram, and a picture of what was going on. I then solved for my R values for steel and fiberglass, allowing me to solve for a total R. With that total R and the change in temperature given to me at the beginning of the problem, I could solve for a Q dot. And then using that Q dot and different R values, I could solve for temperatures at different edges of the picture there. I then put my process into Excel just to double check that everything I had was right, and I could change a few values just to see how different variables impacted the ending Q dot value. The first parameter I changed was the thermal conductivity of steel. As you can see, that has a linear relationship with the heat transfer rate, which is Q dot, and as you increase the thermal conductivity of the insulation, or even just the metal used, like the window pane, the heat transfer rate will increase as well. Same goes for heat transfer rate in the area of fiberglass. It has a linear relationship, and as you spread the area of the fiberglass out even thinner, the heat transfer rate will increase. Lastly, I played around with the change of temperature a little bit just to see how it would increase heat transfer rate or decrease. Seems to be in the same linear relationship, which makes sense because if you're just sitting at home and it's hotter outside, you feel that a lot more when it's like 90 degrees in your home than when it's about 70 degrees. You don't feel as much heat transfer.